Okay, this is where we left off on our last video. This one is just showing an action potential traveling down an axon. And the next slide here is showing a graph. This is another way we can look at action potentials. What we're looking at on this graph is membrane potential on the y-axis as time goes by on the x-axis. Membrane potential, remember, is just the difference in charge across the membrane. So when we start out here with our purple line showing our membrane potential at -70, what that means is that the inside of the cell is 70 millivolts more negative than the outside. So it's showing a comparison between the inside and the outside. If we were to get up closer towards 0, we're going to be having our charges inside and outside of the cell evening out. That's depolarization. So polarized here at -70, depolarized as it heads up towards 0. We'll see that it actually goes above 0, but that's okay. It's still called depolarization because it's heading in that general direction. So -70 is the resting potential of our membrane. It's the membrane potential when the axon is not firing. When the axon receives a stimulus, and actually receives enough of a stimulus that it passes this threshold line here, it's going to undergo an action potential. It's going to start depolarizing, and so we see our membrane potential moving up towards 0. Remember that what's happening here is that sodium gates are opening. So sodium is rushing into the cell, and that's canceling out some of those negative charges inside the cell. The next thing that's going to happen is the potassium gates open, and potassium leaves the cell, and that's going to be repolarizing the cell. So again, as we get down farther away from 0, we're getting a bigger difference between our inside of our cell and our outside. That's going to be the cell becoming repolarized. So depolarization, sodium enters the cell, and then the potassium gates open. Repolarization is when the potassium leaves the cell. This little undershoot period here, this is where we see the sodium-potassium pump working, and that's going to be putting the ions back in the appropriate place. So putting the sodium back outside the cell and potassium back inside the cell. And once that's done, the axon is now back to normal resting potential of -70. In this picture, we look at how that looks across the whole neuron. So if we had a neuron here where the axon is this stretch here, and if we had little electrodes, little probes that we could use to measure the membrane potential at each spot, what we would see is that the membrane potential changes the way we saw in that last graph, and that happens at every spot along the axon. So these would be the nodes of Ranvier, and the action potential happening in one triggers the action potential happening in the next. So this is what the actual signal looks like. This is an action potential getting passed down an axon. We have the depolarization and repolarization of each consecutive region of the axon all the way down. If we look at the big picture here, we have a presynaptic neuron, and that presynaptic neuron has sent an electrical impulse or an action potential down its axon. Eventually, that action potential reaches the axon terminals. And the axon terminals are going to be found at that synapse, the space between the presynaptic neuron and the postsynaptic neuron. Once our electrical impulse reaches the axon terminal, it's going to cause the release of neurotransmitters from that axon terminal. That's what's being showed in this little side picture over here. So this little jolt is representing our action potential. The neurotransmitters are stored in little vesicles here in the axon, and when that jolt comes, the neurotransmitters are released into the synapse. The neurotransmitter then diffuses across the synapse, and so in this picture, our presynaptic neuron is this one. Postsynaptic neuron is over here, and so our neurotransmitters are moving across in the direction from the presynaptic neuron to the postsynaptic. Once they reach the postsynaptic neuron, they dock on these little receptors. So these are receptors, they're receiving the signal of the neurotransmitter being sent. Once that happens, we're kind of looking here now, the action potential can start in the postsynaptic neuron. So the whole point of this, we have the action potential coming down our axon. That's an electrical signal. That's triggering this release of neurotransmitters, which is kind of a switch over to a chemical signal. And that chemical signal, once it gets to the next neuron, initiates another electrical signal. It starts another action potential. Here's another picture of that. We have our presynaptic and our postsynaptic neuron. When our presynaptic neuron has an action potential arriving at its axon terminal, the vesicles holding neurotransmitters release into the synapse. So that's shown over here in this box. The neurotransmitters diffuse across the synapse and dock with the receptors on the other side. Now, we're not going to get too much into this, but essentially what the receptor is going to do is it's going to start letting sodium flow in, and that's going to be, remember, that's the same thing that happened here. For an action potential to begin in a neuron, it's the same thing that has to happen for the action potential to travel down the neuron. Sodium rushing in depolarizes the cell. So here we have the same exact thing. We have sodium gates opening in response to this neurotransmitter being received. When sodium rushes in, that's going to depolarize the cell. The cell becomes more positive inside. Once the signal is over, well, the signal will end once the neurotransmitters are gone. And so there's really two ways for this to happen. One is that the neurotransmitters can be broken down right there in the synapse. They can be broken down by enzymes so that they're no longer able to fit together with the ion channel here. They can also be taken back up into the presynaptic neuron. So that's not shown in this picture, but another possibility would be these little guys, these little neurotransmitters that are released from the ion channel here, heading back into the presynaptic neuron, getting repackaged into a vesicle, and then they're going to just be there and ready for reuse. If the action potential comes again, the neurotransmitter can release those the neuron can release those neurotransmitters back into the synapse. Okay, here we have a little puzzle. I've got the stages of the signal being passed from one cell to another, numbered 1 through 6. And then over here are captions, A through F. Pause the video, try to fill in the correct letter at each of these numbered stages. What's happening at each stage? And then I'm going to go on and show you the answers. So check your work. This is what your answers should look like. If you have any questions, obviously, you can talk to me about it during class, and I hope that this was helpful.